Hi, this is Irv Shapiro with MakeWithTech. I haven't done a review of a 3D printer in quite a while now. I've been focused on some other things, but when Creality reached out to me to look at the Ender 3 V3 Plus, I looked up the specs, and I realized that this printer is not just another Ender printer. Let's compare it to this printer next to me. This is an Ender 3 S1 Pro. It's a great printer. It has a hot end that goes to 300 degrees Celsius because it's the Pro model. The print bed goes to 100 degrees Celsius. This is a wonderful printer I've recommended to lots of people. It has dual Z drive rods that drive the Z axis. It's well constructed. It has a good display. It's not a touch display, but it has a good display. It has a filament out sensor. Overall, it's a great printer, but it's an Ender printer. What do I mean by that? Well, it uses aluminum extrusions to hold the printer together. It has a sheet metal base. There's a lot of plastic on it. The hot end is on wheels that run on extrusions. The Y-axis is on wheels that run on extrusions. It has auto bed leveling, which is an aftermarket, really BL Touch style bed leveling mechanism. And it has a fan. In fact, it has two fans, but they're okay. They do a good job, not a great job. Now, let's look at this Ender 3 V3. It's a completely different type of machine. This is a cast frame. There are no bolts holding it together. All of the moving parts are on steel rods using bearings, a technique, in fact, that Prusa used 3-4 years ago. But the first time I'm seeing that in an Ender style printer. It's a completely new hot end. In fact, it's a hot end that is very, very similar to the hot end on the K series, the Premier series of featured printers from Creality that are really prosumer or even professional grade. It has a brand new style of nozzle and heatsink, and it's running Clipper, not Marlin. And we'll talk more about that in a couple minutes. So this is still called an Ender, but it's a whole new generation of printer. And it's many times faster. 3, 4, 5 times as fast as a traditional Ender printer. A traditional Ender printer, generally you start at about 50 millimeters per second when printing. You go up to maybe 70, maybe you could push it to 100. This starts at 100 and goes up to 500 or 600 millimeters per second with good quality. So I was very excited to take a look at this printer, and I want to answer the question for you. Should this be your first printer? Maybe not this model, the Plus model, the regular Ender 3 V3. Should that be your new printer? Now, it's a little more money than a traditional Ender 3. You could actually get a legacy Ender 3 now for probably about $200. I think you can get an S1, not the Pro model, for probably about $250. This is a $300 printer. So stay tuned and let's learn more about this printer and whether it's the right printer for you to start your exploration of 3D printing, or even more so, is it the right printer for you to use in a prosumer type setting. Stay tuned. Let's learn something together. Now, before I get started, let me share a couple important things. First, I did not pay for this printer. Creality supplied me this printer as a review unit, and in fact they supplied me with 2 reels of filament, actually not this one, 2 reels of silk PLA, and one of them was used to print this absolutely gorgeous vase that we'll be looking at in a moment. Second of all, MakeWithTech is really a collection of educational resources. There's the MakeWithTech.com website, there's forum.makewithtech.com where you can go to ask questions. There's models.makewithtech.com where you can download various models that we talk about in these videos. Now, let's talk about the Creality ecosystem. The Creality ecosystem has really expanded rather dramatically in the last year. It consists of their 3D printers. It consists of a new slicer called Creality Print that we're going to talk about in a little more detail in a few minutes. It consists of Creality Cloud and a smartphone application that works along with Creality Cloud. And because of this ecosystem, you can stay in the Creality environment whenever you're using one of their new, more modern printers. Now, part of what's interesting about that is that historically, Creality's gotten a lot of slack because they use open source components and then they didn't necessarily make their variations available to the greater community. With the components used on this printer, as you can see in this diagram, those components are now available directly on GitHub. In fact, Creality Print is very current. The most recent version of Creality Print, their slicer, is available on GitHub as of 4 days ago. I have noticed some of the firmware, such as the Creality OS, the port of Clipper that's used in this printer, is not necessarily up to date, but clearly they're making an effort to engage more successfully with the open source community and give back to that community. Now, let's talk about this printer. First, it's very easy to assemble. As you can see in this diagram, basically you take the main gantry, you bolt it onto the base. In the case of the Plus unit, you add these two rods on the back, you plug in the cables, and you're ready to go. So it comes with the gantry flat in order to reduce shipping costs, but overall it's 90–95% pre-assembled. That makes it much easier to get started. Now you'll notice this is an open frame style printer. For most consumers, I prefer that. I find fully enclosed printers are more difficult to deal with. When you have something like a jam in the print head, it's harder to get the things if it's fully enclosed. Now on this slide, you'll see all of the new components that are really radically different than any other Ender printers. And in fact have more in common with the K series of professional grade printers than they do with the Ender series of consumer printers. First, let's talk about the hot end assembly. The hot end assembly has dual fans, one in the front and one in the back, so it can blow on your print from both directions. That allows you to print things like these very fine spires, these towers, on this sample print from Kickstarter. Overall, I found the cooling to be very, very good, but like any 3D printer, you are going to need to tune the temperature and your speeds for particular filaments. Because I'm going to show you an example of a print that failed, and we'll talk about why it failed in a couple minutes. The nozzle assembly, which combines the nozzle and the heat break in a tri-metal structure, has an advantage over the original K1 nozzles in that the nozzle itself at the end, you can't really see it here because there's a silicone sleeve around it, but the nozzle itself is hardened steel. That means you can use more abrasive materials in this printer without even changing the nozzle. The nozzle is removable and they ship a wrench, a special wrench for removing that nozzle quickly with this printer. The extruder, which is behind this case, and you can see a picture of it here on the screen, is a multi-gear extruder. Now that's important because this printer can print very, very fast, as much as 10 times faster than some of the early FDM style 3D printers. When you're printing that fast, you have to do a couple things. First, you have to be able to heat up the filament very, very quickly. Then you have to be able to pull a larger volume of filament off of the reel and force it into that heat zone. So this multi-gear extruder is designed to do exactly that. Finally, the motion system on this printer is quite different. This configuration is very unique. This is called a Core XZ configuration. That's because there are two motors mounted here on the base that drive a series of belts that are used for moving both the hot end and the Z-axis. So these two sets of motors, through a set of belts, move the printhead up and side by side. That means there's less weight, there are less motors floating around the top here. That makes it more stable. That's one of the reasons it can print so fast in spite of the fact it's a bed slinger, meaning the bed moves back and forth style of printer. In this particular case, the Plus model, because the bed is so large, there are also dual motors down here in the base for moving the bed back and forth. The bed is on steel rods. The print assembly is on steel rods. So that makes it a smoother motion than if you were using extruders and wheels like the earlier Ender printers. The touch panel allows you to control everything on the printer. You can start a print, stop a print, calibrate the printer, all from this touch panel which interfaces with Clipper. It also allows you to do something relatively unique. With this printer, you can print from a USB key device. You can print from the internal memory. You can print from the cloud, from Creality Cloud, or, and this is very, very interesting, you can print from Creality Print running on your Windows or Mac computer over your LAN without ever going to the internet. So if you have concerns about connecting this to the internet, not just to your local LAN, you don't have to. You can print locally over your LAN or from a USB key plugged directly into the device. The print surface is really quite nice, and they did a couple things here that are very, very nice. Number one, there are little notches here that fit into pins at the back, so you get it on in the same place every time. This is a textured PEI surface. It sticks really well. I didn't have a single print come loose. In fact, they recommend you use a glue stick on this surface if you're printing materials such as TPU or PEG, which stick really, really well, so you'll be able to get them off without damaging the surface. I actually prefer using Magic Glue, which is a product designed for print surfaces, but they also claim from Creality you can use a regular glue stick. Now let's talk about the processors and the sensors in this printer. There are two processors in this printer. One, an STM 32-bit processor on the main board. That's the same processor that's basically been in Enders for a while now, and it controls the stepper motors and monitors the temperature, controls the heating element. But then there's a separate processor to run Clipper. A lot of people that run Clipper separately do it on a Raspberry Pi. In this case, there's a 1.2 gigahertz dual-core processor dedicated to running Clipper. So you can control this printer by connecting it to Wi-Fi from a browser, from Creality Print, or you can connect to it from OpenSCAD, an open source slicer. In fact, Creality Print is a kissing cousin, very related to Orca Print, and it's really a fork of that ecosystem, which in fact is a fork of other ecosystems. Now, in addition to the processors, there's a motion sensor in this hot end. That allows this printer to use a feature in Clipper called input shaping. What input shaping does is it takes and it purposely shakes this hot end very rapidly to see what vibrations are caused in the printer. And then when it goes to print, it adjusts the movement of the hot end and the movement of the very axes in order to minimize vibrations. That gives you much smoother prints. It's very unusual for a printer at this price point to have both input shaping capability, but also the sensor built in. In addition to that, there's a filament out sensor mounted right here on the side. So let's talk about that. So the reel of filament goes right over here. And there's a problem. The problem is that in order to sense the position of this print head, when you home this print head, it goes all the way to the top. And then there's some micro switches over here that are used to sense the position of the print head. That means it pulls a whole bunch of filament out from this reel. Then the print head moves all the way down, and you have this filament sort of hanging out here. So what Creality did is they created this mechanism here that you slide over the reel and keeps the filament from unspooling. And it works pretty well. But in fact, the only failed print I had was a print of a temperature tower that failed because this filament got wrapped around this reel back here. So I'm not a big fan of this. In addition, you can move the print head up when you put in your filament because it feeds in from the bottom, but it's a little awkward to feed the filament in. You feed it through this tube. This is not a Bowden tube because the only purpose of this tube is to guide the filament. It doesn't get pushed through this tube. The extruder here pulls the filament through. So you don't have to even clip this Bowden tube in if you don't want to. There is a little clip to clip it in, but I often find when I'm first loading this, it's easier to load if this guide tube is out. To load the filament, there's a very nice mechanism. There's a little lever here. You push it to the side, you push the filament in, you push it back. That's very well engineered. But one of the changes I'm going to make when I start using this printer every day is I'm going to move this reel of filament probably just to a standalone holder. And I'm going to move this switch to somewhere in the top. In fact, one of the items that I printed for this sample print is a holder for the filament guide designed to sit on the top here. Now, other than that, I sort of liked everything else on this printer. None of my other prints failed. I had one whose quality did not meet my expectations, and we'll go through that when we talk about it. But now, let's talk for a minute about Creality Print. Let's look at this slide together. This slide is a copy of a number of things that are in the README on the GitHub page. Creality has gone to great lengths to identify each of the features in Creality Print and where its original source was. Which features come from Cura, which features come from PrusaSlicer, what features come from the OpenSCAD, the features that come from SuperSlicer, the features that come from Bamboo Studio. They're really taking very seriously this commitment to the open source community. And I really applaud them for cleaning up their act in some ways in this particular case. Okay, so overall, the physical structure of this printer, the construction of the new hot end, the new extruder, the print bed, the ability to control it from the front of the printer, to print locally over a LAN or from Creality Cloud, from the cloud, even using an application on your smartphone, is really excellent. and my print quality was great with two exceptions. The one print that failed that I showed you a moment ago. I'm going to show you another in a minute. Okay, so let's look at print quality. I'm going to move this thing off again because it's just annoying me. It's in my way here. Okay, these are two benchies. And I'll show you close-ups of these. One was printed in 14 minutes. Yes, in 14 minutes. And in fact, it's quite good. And the other was printed in 30 minutes. The 30-minute benchy was using the standard settings, the default settings in the new Creality Slicer. The 14-minute one was printed off the sample that was already in the printer. The primary difference is the 14-minute one looks a little soft. Edges are a little blurry. It almost looks like it was melting just a bit. Whereas the 30-minute one, which is really an excellent benchy, printed really nicely. The type on the bottom is easy to read. The type on the back is a little bit blurred. So I couldn't really read that type. But these are excellent prints. Next, I wanted to look at the speed of this printer. And there's one of the tests that you can do is an acceleration print test, where there are two parameters that really impact quality a lot. How rapidly you move the print head, not when you're moving at steady state, but when you're stopping and starting, how rapidly you accelerate, and then how rapidly you stop. That's called acceleration and jerk. So this is a print cube that you can print directly from the Creality Slicer. There are a number of calibration prints built into the slicer. And it starts at acceleration of 500 millimeters per second squared and went up to 10,000. Now, to be very honest, I couldn't tell much difference between them. At the very top, the edges are not as sharp. There's a little bit of rounding on the edges versus very sharp at the bottom, but any of these speeds, in my opinion, would be just fine. Then I took and I printed a print from Kickstarter. Now this print I've been printing for 3 or 4 years now because it does a good job of testing a variety of features. One of the things it tests is the ability for the printer to print in tight tolerances. It has these pins with a space of from 0.2 millimeters to 0.5 millimeters between the side of the pin and the hole. All of them came out without difficulty, which says the tolerances on this printer are excellent. It has a series of bridges. Those are good, not the absolute best I've seen. All these towers at the top came out very good. It printed all of them to the very top, which means flow control is working well, but there was a little more stringing than I would like, so I may have to fine-tune the temperatures. And I was going to do that with the temperature tower, but that print failed, and then I wanted to go ahead and start making this print. On the bottom, you can see how well the fans are working because these overhangs are very, very smooth. So next, I wanted to see if I could print at high temperatures. So I love a filament called ColorFab XT, but it requires at least 230 degrees Celsius. I printed this at 240. This printed beautifully. This actually snaps onto the top, and it's a bracket for remounting the sensor I spoke to you about just a few moments ago. This is an excellent print. Then I wanted to print some things that were a little bigger. So I printed this enormous vase in spiral or vase mode. This is printed using Creality Silk PLA that they sent me as part of the evaluation. And this is a really fun print, and it's beautiful. It's just a beautiful print. Next, I wanted to print a print that was very functional. So I printed this reel holder that snaps on the top here. I'm probably not going to use it because I think the idea of putting this weight on the top is not a great idea. It will cause more vibration. I'll probably just use a standalone reel holder and just move the filament out sensor. but I printed this in MatterHacker Tough PLA, which is a really nice filament for functional parts. Now let's look at a print that failed. Now this Eiffel Tower looks great until you look at the details, and you can see inside here many of the features didn't print properly. And when I compare it to this one, which is clearly a little bigger, the features are all there. And in fact, see this rail along the outside? That rail didn't print at all. Now, some of it is because I printed this bigger. This was printed on a Delta style 3D printer where the bed is not moving. So I thought maybe that could be it. Maybe it's because I used a higher layer height, and so the pieces were all the extrusions were a little thicker, and all those things have an impact, but it really bothered me that things were missing. So I went into the Creality Print Slicer and I looked at the preview. They were missing in the preview. This was a slicer error, not a printer error. So I downloaded OrcaSlicer, which is a slicer that's very similar to Creality Print and also supports its printer. And I looked at the preview there and all the features were in the print. Now this is a 8 or 10 hour print. I didn't have enough time to reprint it, but it just goes to show you that it's not just the printer. It's the overall ecosystem. It's the slicer you use, it's the filament you use, it's the printer you use, and they need to work together. So there's clearly some bugs or some settings I need to change in Creality Print in order to print very fine details that did not work for this. So I wanted to find out if Creality Print was just plain broken. So I looked at this other print, which has a lot of details, the same type of weave, but they're a little thicker. And this printed beautifully. This is one of the best prints I've ever printed. And so I know now that Creality Print can handle it in most cases. This might be an anomaly, this particular print, but this print came out really beautiful. Okay, so what's my conclusion? This is a great printer. If you can spend $300 for the standard size version, not this 300 millimeter high version, so it'd be the Ender 3 V3, which is the size of basically a standard Ender. This is an excellent, excellent printer. If you want to spend less than that, I think there's some other printers you can look at. You can look at other Ender printers from Creality. I think the AnchorMate printers, which are a little bit less expensive, are also very, very fast and a very, very good printer. You can see one of those behind me. I've reviewed that in another review. But overall, in particular in this large format size, for a large format printer where you can print remarkable things, and I am going to print one of these in the larger size from the OrcaSlicer, this is an excellent, excellent device. So folks, I hope you learned something today. Oh, by the way, this is a camera you can get for about 30 bucks. I bought it on Amazon. This is the Creality camera. It just plugs in and then you can do time lapses on this printer directly. So I hope you learned something today. If you did, please give me a thumbs up, like the video, do all that stuff. Go to forum.makewithtech.com to leave comments or leave comments down below. Go to our website at makewithtech.com to learn more about us. Have a great day, and let's continue to learn things together.